problem, we have A equals 5. So what could A be that would make this 5? That is, what are the points that are 5 away from 0? And so if it was just the absolute value of 5, that would equal 5. But there's one other one that would work as well, and that is negative 5. If I had the absolute value of negative 5, that's also equal to 5. So if A equals 5, then A could be equal to this one. So A equals 5. Or A could be equal to this one. It's negative 5. So we have two different solutions. A could be 5 or negative 5. In either case, when you take the absolute value of it, it's going to equal positive 5. So now let's do a more complex one like this. And the first thing we're going to do is try to isolate our variable, or isolate the absolute value part of it right here. So to do that, I'm going to use balance. I'm going to subtract 5 from both sides. So that cancels this piece. So I'm left with negative 4 times the absolute value of negative 2 plus 3a equals 1 minus 5 would be negative 4. Then trying to isolate this again, I have negative 4 times that. So I would take the opposite of times negative 4 is divided by negative 4. I'm going to do that again to both sides for balance. Whatever I do to one side, I got to do to the other. So the negative 4's cancel. Times negative 4 divided by negative 4 just goes away, equal to 1. So on the left-hand side, I have the absolute value of negative 2 plus 3a. And that's going to equal negative 4 over negative 4, which is equal to 1. Okay. So now, just like if I go back to this one, in this case, A could equal either 5. Whoops, A could equal either 5 or negative 5. So now here I have the same sort of thing. This thing inside here, that thing, negative 2 plus 3a, has to equal 1. Or this thing inside here, negative 2 plus 3a, could equal negative 1. Because if this whole thing equals negative 1, and I put a negative 1 inside the absolute value, that's going to equal 1. So I have to actually do two equations to solve this one. But I can solve them the same way. So just trying to isolate my variable, isolate the 3a, the first thing I'm going to do is add 2 to both sides. So when I do, that cancels. I have 3a equals 3. I don't want 3a, I want a alone. So instead of 3 times a, if the opposite of that is to divide by 3, I do that to both sides for balance. And so a equals 3 over 3. In this case, that would be 1. Okay, but I could still do the 1 over here. Once again, I'm going to add 2 to both sides. And I end up with 3a equals negative 1 plus 2 is just 1. If I divide by 3 on both sides, the 3's cancel, and I'm left with a equals 1/3. So my final answer is a equals 1 or 1/3. All right, let's take a look at these first 4 example problems. The first one is just a equals 3. So what could be in here that would make this 3? Well, the absolute value of 3 equals 3, and the absolute value of negative 3 equals 3. So a could be equal to either 3 or negative 3. For this next one, we want to try to isolate the absolute value of x, isolate that part first. So if I divide by negative 3, because it's currently times negative 3, so if I divide by negative 3, those are going to cancel. And of course, balance tells me that whatever I do to one side, I have to do to the other. So I divide this side by negative 3. So I'm going to end up with the absolute value of x equals negative times a negative is a positive. 15 divided by 3 is 5. And so now it's looking a lot like this one over here, where what could x be that would make this 5? Well, if x is equal to 5, the absolute value would be 5, or x could be equal to -5. In either case, then the absolute value is going to be 5, so our answer is going to be either 5 or -5. In problem number 3, I want to try to isolate that part right there. So the first thing I'm going to do is subtract 3 from both sides. And when I do, I'm going to have 3 times the absolute value of v equals 9 minus 3 is 6. If I don't want 3 times this, the opposite of times 3 is to divide by 3. And if I do that on one side, I need to do it on the other side because of balance. And so I'm left with the absolute value of v equals 6 over 3 is 2. And so what could v be? Well, if v was equal to 2, then the absolute value would be 2. Or, of course, v could also be equal to -2. So if v is equal to either 2 or -2, that will get me the correct answer here. All right, so for this one, we have m plus 3 equals 7. So what that means is the part that's in the absolute value, this m plus 3 here, this m plus 3, if this were equal to 7, then this would work. But also, if m plus 3, if the part in here were equal to -7, then this whole thing would be equal to -7. When it's the absolute value, it would be equal to 7. So that would work well. So actually, I have to solve both these equations because m plus 3 could equal 7 or m plus 3 could equal -7. So to solve these, if I just subtract 3 from both sides, balance tells me I need to subtract from both sides. So m plus 3, the opposite is -3. That disappears. So I've got m equals, in this case, 4. If I subtract 3 here and subtract 3 here, once again the 3's cancel, so m would equal -10. So in this case, m equals 4 or -10. If it's equal to either of those, then it will solve this equation up here. Number 5, the part that's inside this absolute value, if it's equal to 8, then we're good. But it could also be equal to, if this part is equal to -8 and we take the absolute value of it, that's going to equal 8 as well. So we're going to have two different equations. We're going to have either 2p minus 4 equals 8, or 2p minus 4 would equal -8. Because again, if this part in here is equal to -8, the absolute value is going to turn it into a positive 8. So how would I solve this? I just add 4, in this case, to both sides. I always do doing the same thing to both sides because of balance. The -4 plus 4, those cancel, so I'm left with 2p equals 12. If I divide both sides by 2, because this one is 2 times p, I want p alone to isolate it, so the 2's cancel now. I have p equals 6. And then for this one, once again, I'm going to try to isolate now first the 2p. So to do that, I'm going to add 4 to get rid of this piece. And if I do that, I got to do that to both sides. So that cancels, and I'm left with 2p equals -8 plus 4 would be -4. And now I don't want 2 times p, I want just p alone, so I need to divide by 2. And if I do it to one side, I need to do it to both sides. Those 2's cancel, and I'm left with p equals -4 over 2 is just equal to -2. So for this one, we'll do it up here, p equals 6 or -2. For number 6, this piece here has to equal either 5, or if this piece in here equals -5, it will also work because the absolute value will turn it into a positive 5. So I'm going to have two different equations. 1 plus 3a equals 5, or 1 plus 3a equals -5. So if I want to isolate now this 3a, so to do that I have 1 plus that. The opposite of adding 1 is to subtract 1. So when I do this, I'm going to have 3a equals 4. If I divide both sides by 3, I'm going to end up that a equals 4/3. And I can also do the same thing over here. If I subtract 1 and subtract 1, those negative 1s are going to cancel, or the 1 minus 1 is going to cancel. I'm left with 3a equals negative 5 minus 1 is going to be negative 6. If I divide both sides by 3, the 3's cancel. I'm left with a equals negative 6 over 3 is equal to negative 2. So my final answer is going to be, I'll put it up here, a equals 4/3 or negative 2. Okay, so these final problems, first thing I'm going to try to do is isolate the part in the absolute value. So if I add 3 to both sides, then that piece is going to cancel, and I'm left with the absolute value of 3 minus 4r equals 3. Which means, like the ones we did above, that 3 minus 4r must be equal to 3, or 3 minus 4r must be equal to negative 3. So in this case, if I subtract 3 from both sides, subtract 3 here, subtract 3 here, I'm left with these cancel. Negative 4r equals 0. If I divide by negative 4, I get r equals 0. And then here what I can do is I can subtract 3 from both sides. Those cancel. I'm left with negative 4r equals negative 6. If I divide by negative 4, I get r equals a negative over a negative is a positive, and 6/4 reduces down into 3/2. So my final answer is that r could be equal to 0 or 3/2. Our final problem, once again, I'm just trying to isolate this piece right here. So to do that, I'm first going to add 5 to both sides to cancel this part. So when I do that, I'm left with 4 times the absolute value of negative 2 plus 2r equals 8. If I divide this whole thing by 4, I'm going to be left with the absolute value of negative 2 plus 2r equals 8 over 4 is 2. So what that means is that I'm going to have two equations here. I'm going to run out of space, but we can make this work. I'm going to have negative 2 plus 2r equals 2, or negative 2 plus 2r equals negative 2. If I add 2 to both sides here, those cancel. I have 2r equals 4. If I divide by 2, I end up with, over here, r equals 4 over 2, which is just going to be 2. And then for this one, if I add 2 to both sides, these cancel. I'm left with 2r equals negative 2 plus 2 is 0. If I divide both sides by 2, I have r equals 0 over 2 is 0. So putting it all together, I have r equals 2 or 0. So again, there could be one that's called a special case where there's no solution. So for example, let's do this one. I want to isolate this piece here. So the first thing I'm going to do is I'm going to subtract 5 from both sides. That cancels. I'm left with negative 6 times the absolute value of r plus 4 equals 6. If I now divide both sides by negative 6, I'm going to get the absolute value of r plus 4 equals negative 1. And remember what we said is anything inside the absolute value, as soon as you put the absolute value signs around it, it turns it positive. Yet this one is saying the answer is going to be -1. And so the answer to this one is going to simply be no solution. There is no value of x, or sorry, no value of r in this case, that I can put in here that when I take the absolute value of it, it's going to be negative, because anything I put in here is going to immediately turn positive.